Okay. Let's do this problem here. Yeah, permutation choice. Given a collection of numbers, nums that might contain duplicates, return all possible unique permutations in any order. 1, 1, 2, 1, 2, 1, 2, 1, 1, 1. So we can use the same numbers, but the order is a actual thing. Okay. 1, 2, 3, 1, 2, 3, 3. Okay. Okay, so this one is a little bit different from the first one. Definitely still a backtracking. Anyways, Merry Christmas to everyone that celebrates. Okay, so let's do this. One, 1, 2. So let's think about this. We can take, obviously from a state of 1, we can take a 1. From here, we can take, the problem is I don't want to take itself again, right? So I can take a 1. Well, let's pull up the excludra. So let's do a diff. So we can take here. I can take obviously nothing from our pile of, it's like 1, 1, 2. I can take 1, 1. We can take actually there's a lot of ones we can take actually. We can take the first one, we can take the other one, or we could take the 2. Right? From here I can take obviously itself, and then what else? I can take the other one, right? Or I can take just like this. And then from here, I can take obviously itself plus this, or I can take like that. Another one is this one. Okay, no. I can take obviously the other one. There's the first one, right? We could take the first one, right? Or, okay, let me fix this shit. So I can take these two. Okay, so I can take here, which is 1, 1, or I can take a 1, 2. And then I can take I think there's only one option out here, so which is 1, 2, 1, which are duplicates. So if I take the same, I don't think okay, so this is 1, 1, 2. So if I have a same starting point, this is the same outcome as this. So there's no even point of looking like at that, right? This one I can take a 2, a 1, right? Or I could take a 2, 1, but that again, that's a duplicate. We don't really care for that one, but that's still a possible one. And then this one right here, 2, 1, 1, both of the ones. And then the other one is, again, this results in the same output. So there's a lot of duplicates, right? So that's 1, 2. This is get that rid of that, get rid of that. 3. So there should be 3 total. Basically, and then I think we can just keep track of a set. We'll just generate all the possible outcomes and then have a set. I think that's the best way I can think of it. because there's gonna be like paths where I take like this whole path here is pointless, but it's kind of hard to exclude it out of the solution. But let's just try it. Let's keep it simple. So we have a res here. We'll do def backtrack. We'll take cur here. And then we'll call backtrack on an empty list and then return res. Relatively the same, right? So if cur or if nums, okay, so if length of cur equals length of nums, res.append cur, let's make a copy of it, return out. And then for every n in nums, if n in cur, I say not in, I'm gonna see, you know what? Let's make this a set, and then, let's make it a set. And then make this a list. So I can have a better... Bro, what is this shit, bro? I don't know why this process manager keeps popping up. Okay, so anyways, if... Ah, shit, okay. Yeah, that's fine. If n in cur, that's the problem too, because I can't even say if it's not in cur. So I think I'm gonna do this instead. I'm gonna use indexes instead. So for every I in range, shit, okay, I see. Let's do, okay, let's have one, okay. Let's have, a set, and we'll also have scene, which is just, pair of tuples. Tuples. Something like that, you know? Because I need to generate correct indexes. Like, I don't want to reuse the same index. That's my main concern. So let me do this. Let's do basically, okay, so for every I in range of length of nums, okay, I'll have two things. Cur values and cur indexes. So, and then we'll do, obviously the cur and yeah. Anyway, so for every I in j that, if cur value, cur index, if I in cur indexes, dot append, okay, what am I doing? Not in, I'm gonna say not in. If cur values, I say we'll do cur values, which is nums of I, dot append nums of I, cur indexes, dot append I, if I not in cur indexes, and then backtrack with the cur values and cur indexes. Okay, so, and then we need to pop those out. Let me change these. And then cur values dot pop, cur indexes dot pop. Okay, maybe this might work. This will also prevent me from using like certain, like I'm gonna, these are gonna be different. Like this is being like technically saying index 1 0 2, right? But this is clearly 0 1 2. They're different, you know, variations of each other, but in our set it's gonna prevent me from adding it because we've used that already. Definitely not memory efficient, but you know, it'll do. Unhashable. Oh shit. Okay. I'll make this a tuple. Okay. And then God, this is gonna be atrocious. Res. Okay, yeah. I think this works, maybe. Wow, very interesting. Well, not that efficient, but I think it'll do good enough. Let's see the editorial. So backtrack, yeah. So backtrack, combination, counter. That's a little smarter. That's a little bit more efficient. Ooh, BT. Okay, it's good enough. Anyways, see you guys tomorrow.